is our water quality. And so yes, this is being recorded. I don't know if folks just heard that pop up. We're going to share this online after the fact. So yes, that's happening. So when we look at trying to determine what the environmental conditions are, obviously we're a very small staff, but we know this local region, so we have some eyes on the ground and are able to do that pretty readily. We're situated here and we clearly have a strong interest, but there's others that have an interest and also have a responsibility, starting from the United States Environmental Protection Agency, that is the steward of the Clean Water Act, and that kind of trickles down from monitoring requirements that are overseen and adhered to and reported on by our local Connecticut State Department of Energy and Environmental Protection. USGS, as I mentioned before, is another great data collector. They are professional scientists, and their tagline is great, science for a changing world. That's really the crux of what they do. University of Connecticut is another great partner. They have some great online tools like this CT Eco, Environmental Conditions Online, to make this data available and usable and visible and just kind of generally accessible. And our local Council of Governments is another great data repository, data collection partner when it comes to regional planning, looking at transportation, population, infrastructure, parcels, community dynamics as a whole. NOAA, the National Weather Service, weather data. We're recently working with this North Atlantic Aquatic Connectivity Collaborative, NAC, which we'll hear more about. And UConn also has a wonderful Center for Land Use Education and Research. So again, some more tools. There's data everywhere. There's a lot of iterative processes. There's a lot of collaboration. And you'll see kind of how that all plays together. You'll see where some of this data collection, how it gets applied and how it gets utilized in the real world. And we'll come back and visit that towards the end as well. So let's start with, how is the Pomperaug? For the most part, we have class AA and A waters, which means they could potentially be drinking water supplies based on criteria that they meet. Class B here in Connecticut is waters that are downstream of a wastewater treatment plant, for example. So, and that cannot be used as a public water supply under our current framework. But for the most part, here in the Pomperaug, we have class AA and A. So generally high quality water, and that's also true for the groundwater. And our streams generally support aquatic life needs. So there's habitat, there's not a lot of barriers, channelization, channel modifications. Our recreational uses are supported based on the bacteria levels, and we'll talk more about that as well. But there are areas of concern. We do have areas where there's been channel modification over the years. We do have stormwater inputs. And increasingly, we're having some presence of invasive species that we're starting to tackle. So, whoops, I just hit a mouse button that I didn't mean to. I'm going to just tease the Connecticut Environmental Conditions Online advanced viewer map here. You can get to their viewers using this link, and it's also just been dropped in the chat. There's different layers you can turn on and off here and look at surface water quality. You can look at groundwater quality. You can look at, there's a lot of layers you can turn on and off and actually kind of get a general sense of what's going on. You can look at water quality impairments. You'll see that further down here. But generally, we have a pretty healthy watershed, but we do have areas that we're looking out for. So I guess I have to click the mouse. It doesn't like it when I try to use the arrows. So we're involved in some of the assessments. A lot of these are being done in collaboration with Connecticut DEEP and through either protocols that they've developed or funding mechanisms that have made some of our other monitoring possible, some other collaborations, utilizing data from USGS and when we look at stream flow and groundwater levels. So this is just quick at a glance, and we're going to dive right into some more detail on each of these efforts for stream assessments. So we'll start with our macroinvertebrate sampling. This is one of the programs we've been involved with volunteers for the longest duration. I think we joined in with the RBV program in 2006. And we go out every fall and collect these little creepy crawlies at the bottom of the river. and this is a great indicator screening, kind of a presence absence assessment, just to give a general sense of, could this be a high quality stream? And there's certain species that are really sensitive to pollution and changes in their environment. They particularly need cold water, oxygen rich water. They need a certain type of habitat, riffle habitat. And they're sensitive to temperature changes and as well as pollution entering their environment. So if we find at least 4 of these different species, we can give a sense that this is a high quality stream. And this is statewide data collection because resources are limited at DEEP. You know, their team is not a whole lot larger than ours. They rely on summer seasonals, but their water quality monitoring team is smaller than, I think, 10 people for year-round staff that are charged with assessing 6,000 miles of rivers and streams in the state. So this is a great program. The protocols are well established and referenced to other water quality parameters, that there's a high confidence that if we find these creatures, particularly the ones in the upper category here, that these streams can be categorized as supporting aquatic life. A lot of this is trout food. And so presence of these guys, there's correlations with the fish community data and other indices. So this is one of the metrics that feeds into the state's integrated water quality report to Congress, which comes out every 2 years, and gives an assessment of, do rivers and streams support aquatic life, and or do they support recreational uses? So, so this is a great way to get out farther and wider to streams that DEEP may not be able to assess. We have, I think, over the years, there's at least 15 sites that we've looked at, like evaluated, and we've kind of divvied them up to an every other year cycle now. But we are trying to reach out to newer sites that we haven't surveyed before. It's kind of a treasure hunt. We're trying to find these high quality streams and get them assessed and ranked. So that's one piece of the assessments we're doing. Volunteers are trained and come out and join us in the fall. So that is our macroinvertebrate program. And like I said, DEEP is kind of the driver behind that in terms of the protocols. They also have some great protocols for monitoring stream temperature. And we've got, oh gosh, I just lost the number of sites on that. Upwards of 13 sites that we're sampling, monitoring for the stream temperature. And our sites are based on trying to identify cold water habitat that may need some extra diligency to protect. We're trying to get some baseline data. So, you know, as we live in a changing climate, trying to understand how that's changing and what those implications may be. We're looking at, are there areas where there's stormwater input that might be coming off a hot parking lot that may need to be mitigated, and how is that changing the stream community? and also looking at, basis for restoration and protection efforts. So like I said, are there areas that we need to bolster shading on the stream to keep it cool, or are our restoration, when those go in, are they effective? So so that's been a great program for us. That's what we started yesterday. I'm going to hold up to the camera here. I got black on black, so I apologize. These are our data loggers, and we stick them in some cinder block housing, as you can see in the photos here, and they're set to record temperature every hour from June 1st through August 30th. 31st, I forget how many days are in August at least, but we usually leave them out until October, and then we bring them back in, download the data, crunch that data using some scientific research from DEEP that has established kind of 3 sets of criteria. We're looking at the July mean, July max, and then the June through August means as well. And that will help us categorize the river stream as cold, cool, kind of transitional, or warm. And we're now just last week kind of launched a 2.0 beta version of a stream temperature interactive map for our watershed. So I know these points on here are rather small on the screen. They didn't translate quite as well, but you can see where those stations are. There's a couple different color codes. So our green are cool, not transitional, orange are cold sites, and then blue are cold or cool transitional to cold. They're so not kind of meeting 2 out of the 3 criteria, but they're on the cooler end of the cool warm spectrum. So this map, folks can jump in. It's interactive. There's a legend that you can drop down to understand what those results are. You can click on a point. It's going to pull up a dialog box. If you click on the site data, it will bring you back to our website. And you can actually view by year, what is that summarized July through August mean, July mean, the max daily mean, and what the thermal regime assignment was. You get a photo of the site. And so it gives folks a nice kind of snapshot of what the conditions have been kind of throughout the years that we've monitored that particular site. And in this dialog box, you can also see like the years that the site's been monitored, like how long has it been established, where it is, like a little descriptor of it, that kind of stuff. So that's one we're really excited about. Like I said, we just launched it, and we think it's a helpful tool. So once you get in there and play around with it, if you have feedback of how we might be able to improve this tool, we certainly welcome it. There's still a few glitches in some of the menu bars and stuff like that. So we're still working them out. So it's still kind of beta, but we think it's a pretty fun tool to share this data, so it doesn't just live on a shelf. So the macroinvertebrates and the stream temperature are one of the pieces of data that feed into this aquatic life support assessment that DEEP does and integrates into the water quality, integrated water quality report to Congress. The other piece that they're doing, and we don't have the credentials or resources to do, they survey the fish communities within the watershed, that both the fisheries division as well as the water quality monitoring group. And again, back to CT Eco, and this is in conjunction with DEEP, they have made the fish community data available as an interactive map. So it's pretty fun. This is a data viewer you can get to through CT Eco. And you can click on all these different points and it will pull up and show you the years that that site was surveyed and what were the fish counts. for what they surveyed. So they're using electrofishing methods. So for example, the site down at the bend of the river, down in Southbury, I'm a trout fisherman, so I'm always interested in trout. They have, and I've been through this section when they've, like nearby when they've surveyed. So brook trout, they're pretty good at avoiding the electrofishing, but there was brook trout and rainbow trout that were stocked, and I think brown trout too as well. Yep. There's American eel in through there. So there's some great species, and that was their most recent, that looks like the 2013 survey. So great tool, again, feeds into that aquatic life support. And most recently, back in the beginning of April, we had Chris Bellucci give a talk about the cold water stream habitat mapping tool that DEEP has just developed, which we're pretty excited about. So this map integrates that fisheries data with the stream temperature monitoring data and identifies areas that have either met the criteria for having cold water species and or stream temperature monitoring data where it's met the criteria for cold water habitat. And so this is a great tool to go in and play around with. You'll see here the Pomperog, I put the basin lines on so you can see it. And we've got some areas in our headwater streams that are definitely classified as cold water that, you know, we certainly have a strong interest in making sure that they stay cold and help protect those brook trout communities in particular. So, so definitely check out that tool. That's an emerging one, you know, kind of newly developed and building those data sets. So we're definitely committed to continuing on the stream temperature monitoring to continue supporting, you know, identification of those cold water habitats and the long-term protections. One last bit about stream temperature monitoring, which I think is pretty exciting. And that is this spatial hydroecological decision system. The SHEDS database, or EcoSheds for short, is a repository for all the stream temperature data. So they have, you know, robust database data management system. And I think you can kind of make out Long Island Sound there. And if that red dot is us. I think that's the red dot I clicked on. That's, yeah, Pomperog River. So that populated one of our hourly data sets. So you can actually view the hourly data for the entire season instead of just the summary. You can download it. You can look at a specific region. And this map is not zoomed all the way out, but a lot of New England, a lot of the Northeast has data that's stored in this EcoSheds. So folks that are doing climate change research or, you know, kind of looking at predictive models for long-term trout populations, academia, USGS, may have a strong interest in utilizing these data sets in their research. So this is all publicly available data, but it's all data that's been vetted. We don't upload our data directly. DEEP kind of is a pass-through first, and then they upload all the stream temperature data into the database. So it's amazing how much data is out there. And it's, you know, kind of refreshing to know that the work we're doing may get utilized in some much larger study that could be a peer-reviewed journal somewhere down the road. So we're pretty excited about that. So with that, I'm going to kind of switch over to more of the kind of recreational uses and maybe some, so that's going to be the bacteria, nitrate, and conductivity. And then we'll talk a little bit about the stream walk assessment surveys and how that supports some of the bacteria monitoring we're doing as we're trying to figure out where things are coming from and get into the culvert and stream crossing assessments. And kind of lumped all these together because these projects are ones that our summer interns are involved with. Obviously, warm weather is our field season. It's when people are recreating, so that's when we want to look at bacteria levels and aquatic life use, or recreational uses, and flows are low in the summer. So doing things like getting in and doing a stream walk, it's a lot easier in the summer when the flow is low. It's not quite as precarious walking up and down the stream channel when it's a little drier, although you do have vegetation challenges. So there's trade-offs. So just quick, images of our SIMR team out there. These are high school and college age students, and we have a team of, call them our Youth Conservation Corps. And this season we'll have 4 young adults working with us as we dive into these assessments, and we're excited to bring them on. They're always a great team and keep us on our toes, and lend to collecting some useful data that we can use in managing our water resources here. So I've alluded to this integrated water quality report to Congress a few times. This is a screenshot out of the most recent one. I just did a quick screen grab of this graphic to show the recreational use support, these assessments. So this is in particular areas that may have high bacteria levels. There are ones that they're listed on this list called the 303D Impaired Waters List. We have a couple segments that have been sitting on here for a while. There's some older data sets that triggered these impaired listings, and triggered us to develop a watershed management plan, watershed-based plan, to remedy, track down, correct where some of these pollutant inputs may be coming from. And as we got into the process, we realized we really needed some more data to better understand the extent of some of these impairments, as well as to understand where the inputs may be, so we can best utilize, leverage some grant funding to implement corrective actions and build relationships with landowners throughout the watershed that are going to be key partners in implementing those types of actions. So we have a grant right now for implementing this watershed-based plan, and that is what is funding our sampling this season. So our bacteria sampling, we have 15 sites that we're going to be out sampling, and on the middle there, it's, we're filling sample bottles. It's not that hard. It's there's just a couple of plastic bottles that we bring over to the lab, and the lab does the assessment, but it does take a little bit of work to get around to those 15 sites, fill those bottles, and meet certain criteria for how quickly they need to be met and processed. And then we are also sharing that data with an interactive map that also just launched last week. This is another 2.0. I mean, this actually might be a 3.0 version of this map. And this one I do want to take you over to, because it's got a little different functionality than the stream temperature one. But same idea, same look, same feel. Get your Pompey watershed. It'll show you all of the sites that we're surveying, whether they're active or not, as one layer. But then you can go in and turn some layers on and off to look at the sample date and what the conditions were at that point. So rather than just looking at them on a table, which you can do, just like the stream temperature site, you can click on that more info and it will pull up that table and show you the numeric values. So I'm going to click on this, and hopefully it continues to share. Anne and Haley, can you just let me know if that's shared? Can folks see this? Okay, Great, thanks for throwing those yeses in the chat there. It's taken a minute to load. I don't know why it's being a little slow here, but we've had some gremlins in our internet lately, so not too surprising. So let me zoom in just a little bit here. And you can view this full screen. If you click this link up here, it'll pop it out and go right to the ESR website, which is the mapping software service that we're using for this. So there's a little, not totally obvious, but you can view the about. If you're on the website here, on the POMPROG site, that info is also pasted below. It gives you a little interpretation of what the results mean. Just being aware that indicator bacteria levels can change widely from day to day. So the data is really only valid for the moment that it was collected because it does change so quickly. But as you toggle through the layers, you can kind of get a sense of, are there sites that may not be as suitable for recreation? If there's, kind of persistently high levels, and that's kind of what we're trying to figure out. We're trying to bracket where these impairments really may be. And so this Wikipemi River is a great example of that. It's a 10-mile long river, and the impairment designation was based on like one season of data from 2010 from one site down here at the bottom of that stream. And so we're really trying to figure out, does that impairment go all the way up to the headwaters or not? So that's why we have as many sites on here as we do. And then I just want to turn off that layer. And this is kind of a striking color coding. Red, typically means danger, caution, stop. We used a red light, green light sort of system here. So red, this was right after Tropical Storm Isaias last year. So we definitely had some precipitation. We had some runoff. You could also look at, whoops, let me hit the layers. Oops, sorry about that. It's a beta version, still getting used to how it operates. You could click a different date. And there you go. So green, good, safe at that moment for being able to swim, although not a lot of folks swim in the POMPROG River, and there aren't really any public swimming areas per se. Other than Long Meadow Pond, there's a public beach, but everything else is just kind of a general wading, fishing. People don't really boat. There's not any designated beaches. So, so that's that map, that effort, and kind of speaking to that, we're really trying to track down and figure out where the issues really are. And then we're going to be coupling that with doing some stream walk assessment surveys later in the season as we really get into those low flow, looking at the riparian conditions, looking at land uses. As we're out there, we'll note withdrawals, other discharges, taking a broad look at in-stream conditions like habitat, bank stability. We walked Transylvania last summer, so this is a very steep bank eroding that you notice there's no trees up here. It's a hayfield, so it's and very sandy soils. Site that might need a little attention and a little stabilization, some plantings, possibly, not possibly, definitely could use some plantings. And looking at some of those opportunities for reducing stormwater runoff and making some habitat improvements is really our objective. So coupling that with our bacteria data is going to be an important step for us to identify places, refine kind of the priority list for where to implement some of these opportunities to reduce the bacteria loads coming into the POMPROG and tributaries. And also while we're out doing those stream walk assessments, we're going to be assessing the culverts, those road crossings that we get to. This is the NAC, North Atlantic Aquatic Connectivity Collaborative methodology. This is happening all throughout New England. HVA, Housatonic Valley Association, has been working largely around our region, and we've just recently joined in to be assessing the crossing structures within our community. So this is really looking at, are these structures sized adequately for aquatic life to be able to move up and down them? So we're looking at height, width, substrate, water depth within the structure, material that it's made out of. So we're really just kind of documenting all the physical attributes that we can quantify. We're measuring length, depth to the road surface, or like height above the structure to the road. And so while we're looking at this through the lens of aquatic life passage, these structures are also conduits for terrestrial wildlife. So looking at, is there a dry channel or dry passage under these structures for terrestrial organisms? And it's a good litmus test based on the metrics that we're measuring, to look at, are they sized adequately for increasing storm volume? So we go out and we're measuring all of these attributes, and we enter that into field data sheet that's actually digitized. And NOC has developed kind of a ranking criteria, so it's weighted based on all of these metrics we put in, and are able to assign from those metrics, is this crossing a barrier for aquatic life or not? Is it a no barrier, insignificant barrier, minor, moderate, significant, severe? It'll let you know if you missed a data piece, and then black. You'll see a lot of black dots here because we just started this assessments last summer, and so we've only done like 25 crossings out of. Then we started in Woodbury. We have 180 in Woodbury. We have another 80 or 160 in Woodbury, 80 in Bethlehem, and 360-ish in Southbury. So we've got a lot of work ahead of us. And this is another cool interactive tool. So I'm just going to quickly flip over to that one. You can select your state. You notice there's a lot of states on that drop-down list. West Virginia even, Maine, Maryland, Connecticut. So I'm just going to click on Connecticut. You can search by town, watershed, surveyor, observer. So I'm just going to click Housatonic, and I'm going to hit search. There's some different methodologies that were used. We're using this NOC protocol, but hit search, and didn't look like it did anything, but it did. It populated this button to view map with Google Maps, or you can download the data file, and it also populated this table. I'm going to click the Google map. And make that a little bigger. And this one is a little fussy with its controls, so bear with me. And it doesn't like to zoom very well. You might just click on one of the points over here, not the Pomparog. But if you click on that data point, it pulls up a window where it shows the photos of the structure, what it looked like at the time of the assessment, and it reports all of those metrics that we measure while we're out there, and then it gives you that classification of, the rating on, is it a severe barrier, no barrier. So this is a great tool for us to be able to share with our public works, town leaders when we're looking at long-term transportation planning at these stream crossings. So I saw a great example here earlier. Here we go, if we get over to the Pomparog. So let's populate. Up on, there's a road over here where there's like, a couple of red dots in the same stretch of road. So if the town's going to pave that road and they're going to dig it all up, or or if something happens to the crossing structure, flooding issues, it kind of flags it of like, this is one that could use replacement sooner than later. So, you know, you got a little stretch of town over here that things are all blue, they're good, but you might have a stretch of road like up here that maybe hasn't had any updates in a while. So it's a great planning tool. So we're pretty excited about that. And, you know, it's a really good example of like balancing those needs. Like we want safe infrastructure for people and transportation, but we also want to make sure we're addressing the needs, the ecosystem needs through that process. So this is a fairly new assessment program for us. As you can see, there's a lot of that work being done around us. So we're pleased to be participating in that. And as we talk about, you know, those storm volumes, and you know, you mentioned USGS a little earlier. We have 3. We're very fortunate to have 3 streamflow gauging stations here in the Pomperaug watershed. This white tower is down on the Pomperaug itself in Southbury, and this gauge has been in operation since 1938, 7, 8. I think it's 8. So we've got 90-ish years of streamflow data, real, you know, like full data record, real-time data that has been essential in terms of predicting, understanding at what point will the river flood, what are those low flow conditions, you know, kind of looking at trends for drought. And then we have a gauge on the Nonawag River as well as on the Wikipimi River. And there's been a lot of funding cuts, and we're fortunate. 2 of our gauges are actually privately funded to operate, and the Pomperaug gauge is not really at strong risk of one to lose funding because of the robust data set that exists. So the longer it's been online, the less risky it is for it to go offline, to have the funding cut for it. So we're really fortunate here, and USGS does have such a strong interest in our watershed that it's not likely to go away soon. Thank goodness. And it is data we use, I won't say daily throughout the year, but we definitely look at it certainly on a weekly basis throughout the year. But in the low flow season, as we get into the summer rearing and growth bio period for the fish community in particular, and we're getting into the, you know, less precipitation heat of the summer, we can start looking at the kind of what is the mean flow, what should it be. That is the kind of yellow delta triangles here, that's the mean flow for that time of year. And then the blue line is the real-time flow. So as we dip below that mean, you kind of say, okay, we're in a little bit of a drought, or not drought, but like it's drier than normal. And then where these peaks start coming up, you can kind of start to see, all right, we got a little precipitation, or this was March, so maybe we had a little snow melt. And you start to see that flow going up. And so that's the gauge. And so when we start seeing those lines dip a little bit, we might start seeing some drought conditions. And we can also look at the flood stage. You know, when we're looking at this graph here, which these are embedded in our website on our Water Watch page. So this is just showing the flow rate. When we get up to, oh gosh, I think it's like 3,000 CFS. I can't remember exactly. This is also measured in feet above like at a gauge height. So about 8.5 feet on the gauge is when we start seeing the river spill out of its banks. And when we start dipping down below 32 CFS, 33 CFS, we're seeing some stress on our fish communities, and we're urging folks to start conserving water. So I'm not going to take you to the Water Watch page because I know I'm having issues with it with my browser, but you can view these graphs on our website. It's kind of a little screenshot of it, and you can click on the title, and that would actually take you right over to the USGS website. And from there, you can actually sign up for alerts. So if you live near the stream and you want to be alerted to, okay, it's really low and I want to make sure I'm conserving water, or I need to evacuate if it starts going up too high, like some of these residents did, then you can sign up and say, okay, alert me when the river gets up to 8 feet. And then when it gets to 8.5, or it gets to 9, and I really should have been out of there a while ago. So those are definitely some tools that we're utilizing. I'm mentioning that low flow number, that 33 number, that's our threshold for starting to see stress on the fish community in that summer month. So that low flow period begins July 1st and goes through October. So we keep an eye out, and we'll send conservation messages and requests for conservation, voluntary conservation, to residents along the river or in the community, not even next to the river, because of that dynamic between the groundwater and the surface water. We also are fortunate, USGS has a groundwater monitoring well down in Southbury. This is actually in the glacial tills, so it's not the stratified drift that directly supports the flow in the Pomperaug River, but it still supports our flow, certainly, as that water moves downhill. And there's a great graph here on the left. The triangles again is the mean kind of average for that month of what we expect to see the groundwater level at. And so that's depth below the surface. And the lower it is, the drier the well is. So we want to see it up in these upper numbers. It's kind of the inverse of the flow. So the depth to groundwater is how far down the well you have to go to hit the surface of the water. This was a graph from 2011, and we were seeing some pretty significant drought there late season. Actually, some of the driest conditions we've ever seen. So this is another valuable tool to us. There's 76 years of record for groundwater monitoring. And these two kind of tools combined, the streamflow data and the groundwater data, feed into the US Drought Monitor. Mentioned the low flow operations plan. These are tools that are utilized in implementing the streamflow regulations that call for releases of water over dam infrastructure, making sure that there's water moving over them as we get into low flow periods. Mentioned flooding risks and also drought risks. And we also want to make sure that our infrastructure is sized adequately for the flows that are going to go through them. So there's a lot of data applications here. Oops, I got two versions of that graph. Two screenshots of the same thing. Sorry about that. This is our low flow page that looks at what those action levels are when we reach certain flow thresholds. So is it, just raising awareness that the river's low, urging conservation, or like really strongly pushing for some voluntary conservation to keep that water in the river. And you'll hear more about that shortly as we start approaching the low flow season. We'll be putting some more communications out about that plan, reminding folks that it exists. And kind of ultimately, with all of this data that we're collecting and all these other data resources that we're tapping into, we didn't talk about land cover data. We didn't talk about land use data. So, what is that composition of, what does the landscape look like here? That plays a key role. How much impervious cover is there, for example? How much precipitation are we seeing? There's a whole host of other data sources that we utilize, and we're trying to bring them together. So between the data we're collecting, data that's available through some of these other sources, You know, we're supporting feeding data kind of back and forth, following similar protocols, sharing that data. We're ultimately working towards trying to develop something like this on the right, a water quality report card of sorts, you know, looking at kind of what is the broad condition of the water, you know, rivers and streams and groundwater here in the Pomperaug watershed. And, you know, probably something we'll be looking to do every couple years, just because we are such a small staff and our resources are limited, and we're still, you know, just kind of establishing some of these data sets ourselves, but wanting to put out something together that's fairly user friendly to understand and share those results. So that's something folks can look to see from us coming down the road, and utilize that tool to think about, you know, what are some of those practices you can do in your own daily existence, or as you live in a watershed, and how can you be a steward to ensure the long-term health of these you know, essential water resources, the vital water supplies we have. So we've got some great tips, this kind of little boiled down version, but you can check out the riversmartct.org website. There's a pledge there, but there's also an amazing library of resources on rain gardens, streamside buffers, you know, composting, recycling, how to dispose of hazardous waste, all kinds of different easy actions folks can take to help make a long-term difference in the health of our rivers and streams. And as always, like, if you see something funny, let us know. If there's something that just doesn't look right, you know, you see rivers looking a funky color, there might be an algal bloom, or there might be a discharge, you might have seen a spill. Let us know. You know, we've got some ties in with the local health department, also the town and DEEP, where we can maybe get a direct channel in, but there's also reporting mechanisms through those avenues as well. And depending on severity, it may need to be reported to that level. But if it's something you're just not quite sure and you want to know more about what you might be seeing, you can give us a call first or email us. And as I mentioned earlier, you can certainly reach out to us if you're interested in coming out and being a volunteer. We welcome the help. And with that, that's a lot of talking, but I did it in an hour. And we certainly have some time left here. So if there are questions, we would love to answer them. So Anne or Haley, do you want to let me know what's going on there in the chat?
We have a question from Glenn. My dog is just barking.
Hi, Bandit.
I apologize. Glenn was asking if you can quickly define channel modification.
Yeah, so channel modification in particular, we're kind of referencing areas that may have been channelized, which means the channel was straightened. Actually, in this last picture here, the one that's really snowy, this is a section of river. This is the Wekapimi, where it was channelized. So instead of seeing some nice curvy meandering section of stream, this was a section through a farm field where, you know, farmers like squares, rectangles. And this was also an area that was severely flooded in the 1955. And so there were some modifications made to make that a nice straight channel so water would quickly move out of that area. And when you channelize a river, you're going to see, one, the change in that flow in terms of how quickly it moves through. And that can change the dynamics in terms of the channel may start to erode its own bed, and that can lead to separation from the floodplain. It also eliminates a lot of important habitat. So you don't have the same pools and riffles, side channel that are really critical for spawning and rearing and growth. You don't have the same deep pools where, you know, things like trout really find refuge in the hot summer months. They like those deep pools where there's cold water, groundwater feeding in. And so those are some of the things that we see with channel modification. And there definitely are a lot of areas that have been channelized throughout our watershed, and some beginning efforts to reintroduce some structures that can help mitigate that. Down at the bend of the river, we've got some great examples of some woody debris that was installed in the river to help create some diversity in that habitat. And the river's changing there and it's got room to move. And so that's exciting to see some reintroductions of riffles and pools. So hopefully that covers it. Other questions?
I see Anne just responded in the chat, but Glenn also just asked, how will you communicate volunteer needs? You have schedule or dates?
Yes, so on our website, on the events, and we do have a volunteer page, but I think we're going to put it on the events because we do have a schedule for sampling for bacteria. It's going to be twice a month. So generally it's going to be the second and fourth Tuesday, Wednesday. I have the calendar, but we're going to put those dates onto our events listing with a sign up if you're interested in signing up as a volunteer. And we will also, Glenn, since you volunteered with us, we have your email and we'll let you know directly. And we may look at, you know, as we get into the season, we've got a couple of changes on our protocols this year, but actually hosting a volunteer training. And as we move along, be looking for volunteers to adopt a site to help us with that data collection moving forward. So, but for now, it'll be joining our staff and coming out as a second in the field with us. Any other questions? Comments? Tell me a joke.
Glenn just commented as well. We did a cleanup and took a ton of flood debris and trash out of the Pomperaug recently. A ton. Glenn.
I don't doubt it. Glenn, where were you? What section of the river Pomperaug were you in? Just out of curiosity. And thank you for doing that. Oh, I was able to open the chat. I see a question from Sadaf. Will we be emailed a link to this recording? Yes, we will follow up with participants. It's going to be a little bit, it probably won't be until next week at the earliest that we'll be able to get the link out to folks. We've got some time off schedules that we're balancing here with the holiday weekend coming up. So probably later next week or early the week after, we'll get it posted on our website or on YouTube. Not entirely sure which, but we'll get the link for the recording out to folks. Little Something Park, an area of bend of the river. Okay, little, I don't know which park that is, but I still appreciate you doing that. And we're also going to be planning some cleanups. So that's another great point. This summer, as we've been out doing field work, we've definitely encountered a lot of trash. So there's some spots that we're seeing that need some attention. See, I'm just going to scroll up through here if there's anything else. Channel modification we covered, and I think there's also a lot of links, and we will also just mention all of these links. We're actively updating our monitoring page on our website. So if I go back over here and kind of go up a layer, you can always go to the science tab, and then kind of really that science tab and the drop down, you can access the scientific reports. The Water Watch is the USGS gauges, the low flow plan, and then monitoring. And so we're really revamping this section in particular, but we're going to be adding a lot of those links to like CT Eco, EcoSheds, NOC, and some other landing pages for deep as well, like the cold water habitat mapping. We'll link to that, but we'll put all those links. And the other spot you can find a lot of those links currently on our website is under resources. Yeah, it's under this resources link. So it's not totally obvious where it is. We'll put the volunteer dates on the events tab, and you can always learn about other opportunities to volunteer under the volunteer tab, under the get involved. So yeah. All right, looking like we're not seeing any other questions. So I think we'll kind of end it there and thank everyone who jumped in tonight and stuck in here with us. And if you do have questions as you are diving in, looking at this data, you want to get involved, reach out. And if there's things that you want to know more about, we're really just kind of scraping the surface here. So, definitely look for future opportunities to learn, and we're here. We're a resource for you to really understand what's going on in the Pomperaug watershed, and we appreciate you joining us this evening. So always check out pomperaug.org. You can email us at outreach or at info, either or, at pomperaug.org, and we'll be happy to follow up. And so with that, thank you all.